video is on the constant rate of proportionality. And just what that means is you have one thing happening and another thing happening, and they're happening at the same time in the same way. And an example of this, so many real world examples of proportional relationships. And proportional relationships is the key word here. Let's look at this. A giant tortoise moves at a slow but steady pace. It takes the giant tortoise 3 seconds to travel 10.5 inches. So let's look at this, that this is the time that we're talking about. It takes him 10.5 inches, and this is 1 second and 1 second and 1 second. So if it's 10.5 over 3 seconds, to find out how much each second would be, you would divide, and that's 3.5. So we've got 3.5 in each second. So 1 second would be 3.5. And 2 seconds would be 3.5 twice, which is 7. And 3, the situation gave us 3, 10.5. And then we would add 3.5 seconds, and that would be 14. And we would add 3.5 seconds, and that would be 17.5. So this gives us a table of the information. And if you divided, this is X, and this is Y, and if you divided each of these, Y divided by X would be 3.5, Y, 7 divided by 2 would be 3.5, and 10.5 divided by 3 is 3.5, and 14 divided by 4 is 3.5, and 1750 divided by 5 is 3.5. So the constant rate is 3.5 inches per second, okay? And it's inches per second. And you do look at it as dividing upwards. So let's see what this looks like. So suppose the tortoise travels for 12 seconds. How far would it travel? Well, if 1 second it traveled 3.5 inches, then for 12 seconds, I would go times 12 times 12. So 3.5 times 12 would be 41. 41 inches is how far it would travel. 41 inches. Okay, so how would you describe the rate of speed at which the tortoise travels? Well, we just talked about that. We said 3.5 inches per second. That's how the tortoise, this rate of speed. So any two rates or ratios based on a proportional ratio relationship can be used to form a proportion. A proportion is a statement that two rates are equivalent. For example, if you can go 8 miles in 4 hours, if that is equivalent to 4 miles in 2 hours, and that is equivalent, or that's not, that would be equivalent to 2 miles in 1 hour. So as long as these are equivalent, then it's proportional. You would graph it out, it would work out the same every time. It would be a straight line that would start at 0, 0. Because at 0 hours, you wouldn't go any miles. So if there's a proportional relationship between X and Y, you can use the equation Y equals KX. The variable K is called the constant of proportionality. The value of K is represented by the equation K equals Y over X. And that's where I was showing you the Y divided by the X, the Y divided by the X, that equals K. So unit rates are rates in which the second quantity is 1. Well, let's look at the Y over X, the constant rate here. So if we go 14 divided by 7 is 2, and 16 divided by 8 is 2, and 12 divided by 6 is 2, and 20 divided by 10 is 2, and 4 divided by 2 is 2. Since this is the same all the way across, this is Y divided by X, then it means that this is proportionate. And again, whenever you put this on a graph, it's going to go through the origin at 0, 0 because 0 pieces of chicken would cost you $0. And what this is saying is $2 per each piece of chicken. So the equation would be y equals 2x. So $2 for every piece of chicken. So if you have 7 pieces of chicken, it costs you $14. So you compare the rates. If the rates are equal, the rates are constant, and the relationship is proportionate. So this is the same all the way across. It is proportionate. And all of your equations will look like this, either a whole number or a fraction, but it'll be y equals a number, which is a constant, times x. So y over x, 32 divided by 2 is 16. And then 80 divided by 5 is 16, and 16, and 16, and 16. So for every box of candy, you get 16 pieces. And my equation is going to be y equals 16x.
Jackson Conti, if you're in the building, come to the front office, please. Jackson Conti, if you're in the building, come to the front office, please.
So if the rates are equal, the rates are constant, and the relationship is proportionate. So these are equal. So here's my equation, and it is proportionate. And later we're going to show how you can use graphs to find proportions. But just know that these are examples of proportionate graphs because they start at 0, 0, and they're a straight line. And they start at 0, 0, they're a straight line. That represents a proportional relationship. So thank you very much.